everybody, I'm Zaha Tayyib, Mededi intern.
So, in today's video, we will be covering correlation and regression. Let's begin with what correlation is. So, correlation is a statistical measure that expresses the extent to which two variables are linearly related. Now, the correlation coefficient, R, has values within -1 and +1. So the correlation coefficient R tells us two things: direction and strength of a linear relationship between two quantitative variables. So let's talk about direction. How would R tell us the direction? So it's a scatter graph that shows time spent on treadmill and calories burned. And if you can see, it sort of shows an upward slope. So that would mean that our R is positive. Here's another scatter graph, and this shows us number of days a student is absent in class and their performance in the test score. And you could clearly tell that there's a downward slope, hence our R is going to be negative. So the sign positive or negative is going to determine the direction of our correlation graph. Let's talk about strength. So strength of a linear relationship is determined if the R has a positive or negative value of less than 0.3, that means it's weak. And within 0.3 to 0.7 range, that means there's a moderate relationship, or more than 0.7 would mean that there's a strong correlation. So here's an example. If you look at this graph, our R value would be, there's sort of an upward slope going, so that would be a positive R value, but it's not very closely related. So this would be a weak correlation, a positive, weak relationship. Here's another graph, and you can see the points are somewhat closely related, closely packed to each other, and there's an upward slope, so that means our R is going to be positive and moderate. Here is another graph, and this one we see that the points plotted somewhat form a straight upward slope, upward line. So this would indicate a strong relationship. Okay. Now we talk about regression. So regression is another statistical process that estimates the relationship between dependent and an independent variable. So it puts emphasis on how one variable would affect the other one, sort of like a cause and effect. Here is another scatter plot, and it's to do with number of hours a student study and test scores on the y-axis. So regression helps us predict values. Here is a regression line. And what we do with this line is we calculate a couple of quantities in there. So y hat equals b naught plus b1x. What does this mean? Y hat stands for predicted value of y. B naught is y-intercept, plus b1 is the slope, and x is going to be any value of x. So what we're going to be doing is we have a scatter plot, we will draw a regression line on it, and then we will use this line to trace back our values on the y-axis. So here's an example. Suppose a government agency wanted to predict the maximum distance at which the sign would be legible for 60-year-old drivers. How would we make this prediction? So now we're going to use the data that we already have plotted on a graph, make a regression line like so, and now I know that the dependent variable is distance, independent variable is the age. Now using the regression line, I want to know what would be the legible distance for a 60-year-old driver. I'm going to trace back using my regression line. So here's 60, I'm going to trace upwards where it meets the regression line and its corresponding value on the y-axis, and this is around 395 feet, so that would be my answer. Really simple, isn't it? So there's a difference between correlation and regression. Correlation tells us whether the variables are correlated. Regression tells us a functional relationship between these variables. Correlation tells us that variables will move together. As we saw, there was an upward pattern, there was a downward pattern, so these were pointers moving together. Regression is a cause and effect. So if our independent variable was to change, the dependent variable would also be affected. X and Y can be interchanged in correlation graphs. And in regression, we cannot, because one is independent, the other is dependent. Our data is represented in a single point. So every single dot in that curve that we've seen in the graphs that we've seen so far was representing our data. When regression, data is represented by the line. We use that line to trace back to our data. Correlation has value between -1 and +1. Regression has values between 0 and +1. And R, which was a coefficient, correlation coefficient, measures linear correlation between two qualitative variables with respect to direction and strength. By regression, over here we use, now look at that, we use R squared. So we square the correlation coefficient. And this measures, tells us how well the regression line predicts actual values. Right, so now we'll be calculating our correlation and regression using sample data in Excel. Here is our Excel sheet. And so Microsoft Office, a quick intro into it is a spreadsheet software wherein we can organize our data in rows and columns. Our columns are labeled by alphabets over here on top, as you can see, and our rows are labeled by number. And each box over here represents a cell, and each cell has a cell label, name, or a reference. So this highlighted box over here lies in column A, row 1, hence it's called cell A1. And now this is important because all of the functions that we will apply to calculate our measures of central tendency, we will be using our cell names and not values within the cell. Also, another thing is that in Excel, all the formulas begin with an equal to sign. So let's see over here. Okay, so here is an Excel sheet with my sample data, and we will be calculating our correlation and regression here. To calculate correlation, it's really simple. You're going to type in equal to correl in parentheses. You're going to enter your data range, and it says array 1, comma, array 2. So my array 1 could be this, comma, and my array 2 could be this. And it doesn't matter which is 1 or which is 2, because we know that correlation values X and Y can be interchanged. So press enter, and that is my correlation value. I'm going to bring it down to 2 decimal point. So let's take it down. So my correlation coefficient is 0.67. Now let's calculate regression. To do regression, all we're going to do is use its pre-installed function. So we're going to go to Data tab, and under Data tab, we'll go to Data Analysis. Now a tab will show up like this, and I need to find out regression. So I'm just going to find where my regression is. Here we go. Click OK. Now we have another tab opening up. So regression, if you remember, is a cause and effect. So we need to be sure what our X and Y values are going to be. If I look at my data, I can predict that a student studying for so-and-so number of hours is going to perform so-and-so in their exams. So my Y range, which is going to be my dependent variable, I believe in this case is going to be my prof marks. So I'm just going to go and select my range here. Now I'm going to go to input X range, and this is my independent variable. So it's going to be my data in this column. Now I haven't selected any of the labels. If I had selected my labels along with my data sets, I would have ticked on the labels. And I'm not playing around with my confidence level, which is at a 95%, and this is default, so I'll let that be. Now, output options. So output range means that you will be selecting the range of cells and where you want your regression results to show up. New worksheet would mean that a new worksheet down here would open up and the result would be displayed there. And a new workbook means that a new Excel application would open up. So I want my results on this spreadsheet. So I'll select output range and I can select any of the cells out here. So I want to select my cell here. So I'm going to click here and I think I want to go with my cell E36, right? Now, I'm not going to mess around with any of these down here because I'm not performing a very advanced regression function. So let's click OK. And so here's the data. Now, don't get intimidated by tons of new values, new numbers, new variables. This is what we really want to focus on. So look over here, multiple regression. Now, if you see, our value for multiple regression is very similar, in fact, almost same to my correlation coefficient. And R² is 0.44. So I'll just highlight the values that I want you all to focus on. So I would need my multiple R, my R², and my intercept. Right. So what do these values mean? So multiple R is our correlation coefficient. And we know that R tells us direction and strength and has values between -1 and +1. So over here, our value is 0.665. And that means that our R is number one, positive. And there would be an upward trend if we were to plot our values. And number two is that there is a moderate correlation between the two components. R², which is 0.44. Now, R² tells us how well the regression line predicts the actual values and has values between 0 and +1. So our 0.44 would tell us that the value that we predict using our regression line would be weakly related to our original actual value. So if we were to generate a graph out of this and a regression line, this is how it would look like. Either we can find the equation of the line and substitute the x values to predict my y values, or we could draw a regression line and navigate our way using our x value and its corresponding value on the y-axis. And that is about it.
Thank you so much for watching. Feel free to comment below any questions.